Hello. What I want to talk to you about in this lesson is manipulating formulas. Now this is something that I always get a little bit worried about because there's an art to it. There is no 100% guarantee this is what you'll always do and it will always work sort of method. Instead, a lot of it is just practice, which means that if you're going to get really good at this, what you will need to do is grab a formula sheet, look at formulas that we haven't even covered yet, and try to manipulate them for other variables. Otherwise, you're just not going to get good at it as quickly as you should. So basically what I want to do is show you some examples, the way that I would approach some things, and how you can maybe try to follow sort of a pattern to be able to isolate or solve for a particular variable in a formula. Because that's really the sorts of terms we should use. We are isolating for a variable that the formula itself, at least the way it's written on a data sheet, doesn't show itself as being solved for already. There's lots of tricks I hear about over the years for how to quickly solve formulas. Just remember that the tricks are just that, they're tricks. They probably only work in a very limited number of situations. It's better to learn some genuine rules, apply them as best you can, and get the best results that way. So basically, here's what I tell people to always start with. Look at the variable that you're trying to isolate in the formula. Other things are going to be happening to it. You need to find the opposite mathematical operation. So if something's being multiplied, you'll divide it. If something is being added, you'll subtract it. If it's being squared, you'll square root it. Now you have to be careful though. These are all things that you have to be able to say are happening to the variable you are trying to isolate. Doesn't matter if other stuff is happening in the formula, that's its problem. But when you do that, let's say you have to divide by something. What you do to one side, you must also do to the other. As long as you're doing it to both sides, you're maintaining the equality, and we have to do that. Whether it's math or physics, it's all the same. We have to maintain that equality. So we do it to both sides, and we'll be okay. Now there's a third thing that I always suggest to people when they're manipulating formulas, isolating for a variable, and it sounds a little bit weird. You try, probably, to do bed mass backwards. Brackets, exponents, division, multiplication, addition, subtraction. Start with the addition, subtraction, usually. Then work into the multiplication, division. Then probably take care of exponents. That's probably going to result in the best solutions for you. Now, what I want to show you for starters, before we start manipulating the actual formulas then, is just how much this looks like the basic algebra stuff that you would have done in a math class. 5x equals 15. And I tell you that I want you to solve for x. This is not a particularly hard problem. And if we use the right language, the sorts of ways that probably you've talked about it, it kind of makes sense. I want to isolate x. Right now, it has a coefficient, 5. The simple way to move that is divide by 5. The opposite of multiplying is dividing. But if I do it to one side, I must do it to the other. Now, I know that I'm a bad person, but the way that I used to talk about this, especially when I was in school, is I would say 5 over 5 cancels. Now that's not really a fair way to say it. What I should really be thinking instead is that 5 divided by 5 equals 1. That's what's really important. And when I have a coefficient of 1, I don't even bother writing it. So x equals apparently 15 over 5. Now, this is where we have another thing that we have to kind of judge carefully about this. Because in this particular example, if I type this into a calculator, it's going to go ahead and pop up that the final answer for 15 divided by 5 is just 3. Great. But what I do want you to check, especially if you have an Inspire calculator, is if you do something like 87 divided by 9. What you'll find is you get this answer like 9.66666 on some of the calculators, and on other ones, it might just reduce it and still show it as a fraction. The fraction is better. I will freely admit that because from a pure mathematical perspective, it is...
Mr. Perry, can you page 502, please? Mr. Perry, 502.
It is an exact answer. And that's okay. Exact answers are wonderful. The reason we don't want that in physics, though, is we actually don't get exact answers. We measure things in the natural world, the numbers go off. That's okay. And what we instead need to do is look at our final answer, like 9.66666, and then round it off for the correct number of sigdigs. So it's something that if you need my help to show you how to change that setting on an Inspire calculator, I can certainly do it. But you want to do that before you start getting to a whole bunch of big exams and stuff like that. For the time being, what I can tell you is that instead of just hitting the enter button on its own, which will then just show you this fraction, hit the inverse button and then hit the equals button. You'll notice that what you're doing by choosing that second function is above the enter button, there's like a wavy equal sign. It's the approximate value. Instead of shooting back a fraction to you, it'll give it to you now as a decimal, and that's what we need, okay? Now, as far as doing other formula stuff, though, what we would be looking at is like even basic formulas, things that are familiar to us from Science 10. And a few things I want to mention to you about me even writing this formula down. I'll see people write this formula like this, and they're absolutely thrilled. Hey, everything's working out great. No, it's wrong. Voltage equals dielectric constant divided by period. So no, but that's what you wrote down. By changing these letters, which are given to us on our data sheet, using lowercase letters to uppercase letters, you've changed the meaning. Now you might say, well, how do I know that? I don't exactly expect you to know that right now at the beginning of Physics 20, but since you don't know it, you shouldn't go changing things. Write them as they're shown on the data sheet, because that's the correct way. So just don't do things like change lower to upper or upper to lower. They change the meaning when you do that. The other thing is, and this is something that I very much got into the habit of doing since I started doing physics all those years ago, is when I do things like a letter T, I put this little tail on it. The reason is, without it, it looks an awful lot like a plus sign. And especially in some of the formulas we do, it can really seem like you got a plus sign. So I'd suggest throwing the tail in just so that it really clarifies things for yourself. And I know sometimes it means you're writing things the way that you don't normally write them, but that's just how we have to do it, okay? Now, I've got this formula. Right now, the formula as it's written gives us a value for velocity. That's fine. If the question gave me the displacement or distance and the time, and I wanted speed or velocity, we'll get into why those are different later. But if that's what I'm looking for, great, the formula is good to go. But what about when I want to find the distance or displacement? Now you might say, well, I could just put the numbers in and solve it by moving around the numbers. I agree. But there are questions where you actually have to be able to manipulate formulas, bring formulas together, do sort of almost like a system of equations sort of thing. And if you can't manipulate formulas, you can't do them. So what I would suggest is when we're at the beginning of the course and getting used to it, manipulate the formulas now when they're simpler and easier, and it pays off for you later, big time, okay? So I take this one and I say, well, if I was trying to solve it for D, what's being done to D right now? D, I don't care about the V over there, D is being divided by T, the time. So if I want to get rid of T, or at least move it around, multiply by T. Since D was being divided by T, multiply by T. But what I do to one side, I have to do to the other. Again, just like I was showing you before when I got rid of that coefficient, T divided by T is 1. So yeah, on the right-hand side, it's gone. And I've got this, TV equals D. Now actually, really, legitimately, this is now done. Like, this is a good formula. It'll work. Out of a sense of tradition more than anything, we usually write the variable that we've isolated for, the one that we're trying to solve for, we usually write it on the left-hand side. So traditionally what I would do now is I would just take everything in the formula and flip the sides. So I've got this. That's the formula I'd want written down now to use. The other thing to watch out for is you look over at somebody else who's also working on manipulating the same formula, and instead of t times v, they've got v times t. Does that make them wrong? No, because you can multiply numbers in any order you want and still get the same answer. So sometimes you'll have a formula that might look a little or even a lot different than somebody else's, and the formula is still correct and valid. That's okay. Now let me back this up a little bit, back to where we started, because that's the way the formula appears on the data sheet, basically. And I tell you, this time I want to solve for t, the time. Now the problem there is that a lot of times people will look at this and they'll say, well, oh, it's just like the other one. D on the top, I'll divide by d and that'll move it. But there's a problem. The big issue here is time is in the denominator. And I can't just leave it down there, because otherwise everything that I'd be doing in my manipulations would be equal to 1 over t. And I don't want that. I want t itself. So actually what we start with is the exact same steps that we did in the previous one. Multiply both sides by t. On the right-hand side, t over t is 1. So it's gone on the right-hand side. But t's sitting over there now. It's no longer in the denominator on the right, it's in the numerator on the left. That's great. It means that I'm not done yet, because I still need to do the next step, which is I've got t times v. I want to isolate t still. I have to do the sort of in-between step. So divide by v. What I do to one side, I must do to the other. V divided by v equals 1. So there's my new formula. T equals d over v. A lot of times people manipulate this sort of basic even formula wrong, and they get these flipped around. It's an incredibly common mistake. So that's why we got to make sure that we're following all the rules, and we're always solving for variables that are up top in the numerator, not in the denominator. Okay? So nice sort of basic formula, but again, one that it can be very easy to make some mistakes on. Now, there are other formulas that we have to be cautious about with the way we use them. There's a formula that we'll be using shortly for calculating acceleration, where it looks like this on the data sheet. Now, that's probably not the way that you saw it when you did things in Science 10, for example, because it's written a little bit differently. But that's basically because of what this delta symbol means, the triangle. Delta means change. And what you can essentially do in all the formulas that you ever have to care about is, as soon as you see the delta, you can expand it to be on the top. That's the only one that I'm really going to play with here. I can expand it so it's final minus initial. That's what delta always means, really, final minus initial. And in this case, they're velocities. So if I do final minus initial for velocities, final minus initial, it's going to look like that. And what I tell students with this formula is that to calculate acceleration, it's really only useful if you open the umbrella on the top. We want to pop that top part open so we can use it to substitute in the actual numbers that probably fit in there. Okay? And then you can manipulate it for other things. Now, what I would suggest is, like once I pop the top on that one, when I write it, I get a little bit lazy. I'll usually leave that delta off. I'm a bad person. It's there to remind us that it's a time interval. It's a hunk of time that we're looking at. But that time interval is just how much time has passed. So I'll usually write it like this if I'm about to do any sort of manipulations. So again, if I was solving for time, I would want to multiply both sides by t. Now again, you can kind of think of this stuff on the top as being in its own little brackets. T divided by t, cancel out, it's equal to 1. On this side, I have t times a, divide both sides by a, and there's your formula. t equals final minus initial velocities up top divided by a, the acceleration. But what about when you have a formula like that and you have to solve it maybe for VF? Things will look a little bit different because you have to move a few more things around. So let me kind of take it back to this step where I had the formula written like that. And I tell you that I want to solve for VF. I want to isolate VF. Now I told you to do bed mass backwards, which makes it sound like I should be taking care of this subtraction on top first, but I can't. Because everything on the top is being divided by t, I have to take care of that first. I have to first move the t the same way that I've been showing you already. So multiply both sides by t, you get something that looks like that. And so again, t divided by t is 1. So that's just going to be gone. Got something that looks like this. Now I look at it and I say, but I'm subtracting VI. So what do? Well, instead of subtracting VI from VF, what if we add VI? And if I do it to this side, I have to do it to that side. I'm going to get TA plus VI equals VF. That's actually my answer. But again, what I would usually probably want to do is get my unknown variable that I isolated for onto the left-hand side and all of this stuff to the right-hand side. So maybe I rewrite it to look like this. And then you look at your friend who wrote out the same formula, and they wrote it like this. Still okay. The fact that t and a became a times t doesn't matter, still the same thing. Or maybe somebody wrote it like that. It's still VI plus the product of a and t, so again, it's still okay. The only thing is, we can't start like multiplying VI by A or T or something like that. We can't have a subtraction symbol here. But different versions of it can all be correct, and they all show something that is right. So there's other formulas on the data sheet that actually look a little bit weird, even just the way they appear on the data sheet, let alone how we have to manipulate them. And one that's a really good example of that is the formula VF squared equals VI squared plus 2AD. So right off the bat, if I'm trying to solve this for VF, isolate it for VF, it's already not there. I would have to square root this side and square root this whole side so that I would get a formula that would look like that. And make sure that when you're doing the square root on this side, you really are square rooting the side. Top to bottom, left to right, the whole thing, so that in effect what you would be doing is this math and then square rooting everything that you've got. But that's just to get it to be a formula for final velocity, because the formula already wasn't written kind of the way we would expect it to be on the data sheet. What about if we had this formula and we were trying to isolate it to solve it for the acceleration? Well, for this one, I kind of get to do that bed mass backwards thing, because I look at this term right here, and that whole thing has VI squared being added to it. Now, sometimes people get worried. They're like, well, don't I still have to square root this or square root that? No, because I'm not solving for VF. I'm not isolating VI. I don't care about that. I'm going to move them around, sure. But since I'm isolating for A, I'm solving for A, I still have to move those things around, but if they're squared, you leave them squared. So what I would do is, because to this term I'm adding VI squared, I'll subtract VI squared on both sides. That's going to give me VF squared minus VI squared equals 2AD. Great. In one step, I've actually made this a lot simpler for me. By subtracting that VI squared to the other side, I now have actually something pretty simple on this side. Because since I only want to get the acceleration, I look at what's happening, and it's 2 and D both multiplying A. I get to go ahead and divide by 2D. Do it in one step. what I do to this side, I also do to that side. 2 divided by 2, d divided by d equals 1. Oops. My formula is actually finished. Now, one thing I would suggest be a little bit careful about is, because I'm going to do the thing where I flip them around because I want my isolated unknown variable on the left-hand side, is when you do that, make sure that you still keep these in the correct order. It's still vf squared minus vi squared, all divided by 2d. The reason I say that is because sometimes people think that when they're moving things to the other side, these could flip around and become like vi squared minus vf squared. No, they still have to be in that order because you can't subtract things in a different order and still get the same answer. Also, make sure that as you're moving things around, you don't forget the squares. Maybe you would have left them behind by mistake or something. You have to make sure that the squares stay on there as well. Now, what I always recommend is, once people have seen me kind of play around with a few formulas and manipulate them, is honestly grab the data sheet, try picking 4 or 5 of the formulas, randomly even, ones that we've never done, that you've never seen before looking at that data sheet, and just try manipulating them for every other variable. And then we can look at them together and see, do those work out the way that you think they worked out? Quite often, if we can get rid of a few little mistakes that you're making near the very beginning as you manipulate formulas, we can prevent big errors from happening later on. And that's just in the best interest of you being able to solve these problems, so that it's not the formulas in the math end of things that are holding you up. Hope that helped you out.